Friends, in my previous session, I spoke to you about the need of registers in the pipelining stages, and most importantly how exactly the registers are used. All these things I clarified very clearly in the previous session. In this session, I am going to talk about how to trace the data path in the pipelined data path model. For example, if I have to trace the way an instruction is working, I need to do it appropriately. Now you can see that here I have got IFID register in between. Meanwhile, I have got IDEX register in between. I have got EXMEM, I have got MEMWB. So how it works, how do we trace it? I am going to trace the instruction load word from this data path with pipeline. So please understand, whenever I have to represent the right, I need to highlight the left part of the register. Please understand, the right goes left. The right goes left, I repeat. Whenever you have to read, you need to read from the right. The read goes on the right. Now, what are the stages in the instruction? The first stage is instruction decode. So, what do? It's very simple. The first stage is to fetch the instruction. The instruction fetches the first stage, and you can see that here I am fetching the instruction. Fetching is nothing but reading the instruction. So the multiplexer is completely used, the PC is completely used, and I read the instruction, hence I read it from the right, and then I write it into the intermediary register IF and ID. So whenever I write, it goes to the left. Please remember, when I write, it goes to the left. So I have read the instruction from instruction memory. It is represented by a right side. I have written the instruction into the IF/ID register. So I represented by highlighting the left side of the register. This is the first step in the tracing. This is very important. Let's go to the second step. Now I need to read the content from IFID. So I am going to read the content from IFID. So I need to highlight the right hand side. This is wrong. This should not be highlighted. So please don't take it otherwise. This is wrong. This has to be corrected in the PPT. So don't worry about it. This is wrong. Now the IF and ID has to be, the register content IF and ID has to be read now. So when you have to read, it goes in the right. So I read the content from it, and I understand that I need to use this particular registers, and I read the content from the registers also. Since it is a load word instruction, I will use the sign extend completely, and then I will write the content into the IDEX register. So when I write, it goes to the left. So you can see that here I have written the content into the left now. So what is the third step? It's very simple. I have now got the content into IDEX, so I need to read from it, and then I need to move it into the ALU. So I have read from it, so reading happens in the right. So I read from it, and then I push it onto my multiplexer through 1, and I use the ALU completely, and the results are to be returned into the memory. EX/memory register is the one that we are going to write into now. Very simple. I have taken the content from IDEX, I have written the content into EXMEM. That's it. When you write, you need to do it in the left. When you read, you need to do it in the right. Please don't forget. Now, what is load word? Load word is all about loading a particular content into a register, but the address where from the content has to be retrieved is to be calculated through the ALU operation, and that content is to be read from the data memory location. Now, here I would have got the address, and the address is used to read the content from the location. So I am going to read from the right, and I am going to write into the left. The mem read back, the write back stage is here. I am going to retrieve the content from the memory location, and I am going to write it into this register. So this register mem and WB has got the content now. Now the next stage is very important. What I am going to do here is I am going to write it back. So I need to read it from the mem WB register, and I use this multiplexer. I will send the content via this way, and I am going to write it into the register file. The write happens to the left, read happens to the right. Now what have we done is very simple. We have used the registers. We have read from the right, we have written into the left, we have taken the content from the instruction memory, we wrote into the intermediate register, we write it again, we read it again from it, and then we use the register file. Then we move to the next stage, we calculated the address, we went into the data memory, took the content, wrote into the memory write back register, and then we finally wrote it into the register file most appropriately. So this is what we have done, and this is without pipelining. Whatever we have shown here is with pipelining. That's all. This way any instruction can be asked to you in the examination or wherever you go, and this would be sufficient for you to understand the tracing process. Thank you very much for following my channel. I'll get back to you with more content in the near future. If you have any comments, please let me know through the comment section, and if you have any specific queries, you can also ask that. Thank you very much. Thank you.